Hello everyone, welcome to this video series on database management system. So in this video, we are going to discuss about what is dependency preserving decomposition. Okay, so as I explained in the previous videos, for decomposition, we have to check two properties. One is lossless and second one is dependency preserving. So the first one I already discussed in the previous video. So the link to the playlist is given below in the description, so watch it. So the second one I am going to explain in this video. So it is dependency preserving. Okay, so let let me go here. Yes, so what is dependency preserving decomposition is, so in the big table we have set of functional dependencies, right? Let's say you have 3 functional dependencies. So after decomposing your big table into, let's say, 2 relations, let's say R1 and R2, you will get 2 subsets of the previous functional dependency set F in the large table, right? So the subsets are FD1, FD2. So I told you that there are 3 FDs in the original set, right? Now let's say FD1 has 2 FDs and FD2 has 1 FD. Now when you do the union, that is you join these two together, you should again get the 3 FDs. Okay, so such kind of decomposition is called as dependency preserving decomposition. Okay, it's very simple then. So let's see. So I hope you remember this example from previous videos. So this is the original table R, and there are 3 FDs, 1, 2, 3. Now we are dividing this large table into 2 tables, R1 and R2. So under R1 we got 2 FDs, and in R3 we got 1 FD, right? When we join them back, that is when we join R1 and R2, again we are going to get all the 3 FDs, right? So such kind of decomposition is called as dependency preserving decomposition, right? Now looking at this example, it is fine, but what if a problem is given where there is no table and some FDs are given to you? What will be the process? So let's see. Actually, for understanding how to deal with dependency preserving decomposition, we should know 2 concepts. One is we should be able to say whether 2 sets of FDs are equal or not. Okay, that is called equivalence of FDs. And second one is minimum cover. Okay, so in this video we are going to see an example on equivalence of FDs. So let's see that what is meant by equivalence. So when can you say that 2 sets of FDs are equal? So you can say they are equal if X covers Y. So what are X and Y? X and Y are 2 sets of FDs. Okay, one set is X, another one is Y. So if we can say that X covers Y, which is represented as this, so this is read as X covers Y, and we can also say that Y covers X, which is represented as this. If both these 2 things are true, then we can say X and Y are equivalent. Okay, so let's see how to do that with an example. So first of all, how to say whether one set covers another. So let's see here. So to verify X covers Y or not, so what is the procedure is, so we are trying to find X covers Y. So you should take each FD from the set Y. Okay, so this is the set Y and this is the set of FDs X. So take each FD from Y. So let's say I am taking this one. Okay, then calculate the closure of LHS. So you already know how to calculate closure of an attribute. I already shown you in the previous videos. So LHS means A. So they are asking us to calculate A closure, but considering the FDs from X. So to calculate A closure, you have to use these two, not these things. Okay. So then what is the closure of A? So first of all, we should include A. Then from A we are getting B. From B we are getting C. So I can write A, B, C. So after finding the closure, what should we do? If the closure contains RHS, so RHS is B. So is there B in the closure? Yes, there is B. Then we can say that FD in Y is covered by X. So we can say that this FD is covered. Okay, it's very simple thing. Take the FD, calculate the closure of LHS using the other set of FDs, and if the RHS is there in the closure, then we can say this FD is okay. FD is covered. Okay, this is covered by X. So similarly, you take this one, calculate the closure of B. So what is the closure of B? It is C. So RHS is there in the closure. So this is also covered, right? Now take the third one, calculate the closure of A using this one. So you will get B. From B you will get C. So C is there in the C is there in the closure. So this is also covered, right? Since all the FDs are covered, we can say that this Y is covered by X. Also you can say that X covers Y. So similarly, we repeat the same procedure for Y covers X. Okay, so let's see this also very fast. Now we are finding Y covers X. So that means we should take each FD from X and check whether this is covered by these three things. So calculate the closure of A. So closure of A is A itself. From A, B. From B you get C. Okay, so B is there in the closure, so this is covered. What about this one? Again, calculate the closure of B using this one. From B you will get C. So C is there in the closure. This is also covered. So we can say that Y covers X. Since X covers Y is true and Y covers X is true, we can say that these two sets of FDs are equivalent. Okay, so this is how you find whether two sets of FDs are equal or not. So I am going to stop this video here. So in the next video I am going to take another example for equivalence of FDs. So please watch that one also. The more examples you see, the more it is better, right? Okay, so please like the video and share it with your friends, and also subscribe to my channel for latest notifications. And if you have any doubts, please comment below the video. Thank you.